Imagine a perfect program referee. Give it any program and its input, and it returns one of two answers. This program will eventually halt, or it will run forever. It is always right, and it always finishes its own answer. Could such a referee exist? For easy cases, the promise sounds reasonable. A countdown reaches 0 and stops. A loop with no exit keeps going. But the real question is not whether we can run one example. It is whether one algorithm can predict the eventual behavior of every possible program before that behavior happens. Assume the referee exists. Call it H. Now build a new program. D takes another program P as data, asks H what P would do when run on P, and then deliberately does the opposite. If H predicts halt, D loops forever. If H predicts loops, D halts immediately. D never has to run P first, it only flips H's prediction. That construction is allowed under H's promise, because H claims to answer every program question. So give D its own code as input. The question is now, what will D do when D runs on D? This is the self-reference that turns a prediction into a test. Case 1, H says that D running on D will halt. D follows its rule. It sees the prediction halt and loops forever. H is wrong. Case 2, H says that D running on D will loop forever. D follows its other rule and halts immediately. H is wrong again. Those are the only two answers H can give, and both fail. The contradiction is not a bug in D. It proves that the assumed perfect referee cannot exist. No algorithm can always finish and correctly decide halting for every program input pair. That conclusion is narrower than computers can predict nothing. Many particular programs, and many restricted programming languages, can be analyzed. The impossible promise is the universal one total yes or no decider for the full class of programs. That is why real program analysis tools set boundaries. They may limit the cases they handle, and answer yes, no, or unknown. They are useful precisely because they give up the impossible promise. The trap with self-reference, a predictor that must handle every program can be turned into a program that defeats its own prediction.